So very good morning to all of you. Myself was Professor Navi Mirza from Maulana Technical Campus. So we are in previous class seeing the steps for design of angle purlin by using IS 800-2007 guideline and IS 875.1 for head load, IS 875 part 2 for light load, and IS 875 part 3 for wind load. Okay, and the steps by step procedure we have seen in previous class. Okay, so today we will going to solve example on design of angle purlin. So all this, how to calculate, how to find out or selection of the section for the angle purlin and design criteria, check for strength in bending because your purlin having a transverse load in x and y both direction because it is inclined to the your principal rafter on the roof truss. Okay. Then you have to find out design moment, then compare with the design and then interaction equation, that is mx upon mdx plus my upon mdy. That should be less than equal to 1. Then only strength required will be. So you have to check only the strength requirement. So we are not going for the serviceability. Okay. So that is previous class we have seen these steps for design of angle purlin. So today we will solve one example. So step by step solution will be there. So write down example on design of angle purlin. This is like our lecture number 52. Your subject is design of steel structure, and today is 12 December 2 December 2002. Okay. So please click on this. Okay. So that is and color of your wing. So write down design an equal angle purlin. Example on purlin, that is angle purlin, yes, angle purlin design. Right on, design an equal angle purlin, design an equal angle purlin. You may take unequal section also, but here it is designed for equal angle purlin. Equal angle purlin. Okay. Design an equal angle purlin for a roof truss. For a roof truss. So this sometimes is asked in examination, in an examination, having 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 following details, having following details. Okay. So spacing of truss, spacing of truss is equal to 3.5 meter. Span of truss is 15 meter. Length of truss we can say. Rise of truss, it is also given, that is 3 meter. The spacing of purlin is given. Spacing of purlin is given, that is 1.35 meter, and weight of GI sheet, weight of GI sheet, weight of GI sheet is 130 Newton per meter square. Min load on purlin is given. Min load on purlin is given. That is a flip left 1170 Newton per meter square. So you have to design the angle purlin. So this is the given data in the example itself, so no need of repeating and writing. So if I will draw the truss, over the truss angle purlins are resting. This is the fillet angle, and then angle purlin is there. And over angle purlin, the roofing sheet, roofing sheet. This one is your principal rafter. Over that your purlin is there. So two purlin spacing it is given, center distance it is nothing but 1.35 meter, 1.35 meter. Okay. So this is given in your example. Okay. So you have to design angle purlin. And rise of your truss is given. Span of truss is 15 meter. Rise of your truss is given 3 meter. Okay. Spacing between the two truss is given. Yes, you can say that in purlin that is given 3.5 meter, which gives us the span of your purlin, because this purlin is running over the roof truss. These are the purlins. These are the purlins. These are nothing but purlins. Okay, you have to design the angle purlins. You have to design angle purlins. Okay. So first, in step number 1, we have to find out the slope theta. This theta you should know. Okay, because your uplift force, it is perpendicular to the roof truss, the main load. Okay, and your purlin is inclined. So load on the purlin will be in two directions. It may be in x and y direction. So, but the wind load is always in the vertical uplift in y direction. So theta, you know, tan theta is equal to, if I write down to find out the slope, tan theta is equal to rise upon span by 2, or you can write that is 3 meter upon span is 15 by 2, 7 meter. So it will give you the angle theta. So to write out the theta, that is tan inverse of 3 by 7.5. Okay, and this gives the angle theta. Angle theta, that is 21.8 degree. Can verify my calculation. And if I write down the components of horizontal component of theta is cos theta, so it is 0.928, and vertical component of theta sin theta, if I write down, that is 0.371, because we know the angle. Now the load calculation, step number 2, load calculation. Got the difference load and so first we will find out the dead load of GI sheet. dead load calculation. So first dead load from the GI sheet, and that load is given 130 Newton per meter square into the spacing of purlin is given 1.35. If you take the load on the purlin, so half load of sheeting from this side, I will change the color so that you can understand. So half load of sheeting from this side, half load of sheeting from this side. So it will be the spacing of purlin. Okay. So that's why here I have multiplied with this uh, 1.35. So I will get the UDL on the purlin, and that is nothing but 176 Newton per meter. Okay. Similarly, this is the dead loads to the sheeting, and then self weight of purlin also act on the weight. Self weight also we consider of purlin, and for trial one we will assume for trial one, and our assumption is that we will take 100 Newton per meter, the weight of your purlin. So total dead load on purlin you can find out. So total dead load on purlin will be 100 plus 176, 276 Newton per meter. Okay. Now we find out the now we have to find out the lie load on the purlin. Lie load on the purlin. So it is given by IS 800 875 part 2. So lie load on purlin already we have calculated when you find out the final point load. So that is from the table 2 of that IS 875 part 2. So we can find out IS 875 part 2 to find out the lie load. Lie load is also called as imposed load. Imposed load. Okay, lie load is also called as imposed load. So the empirical equation we draw from that table, that is 750 minus into theta minus 10 slope more than 10 degree into 20, okay, Newton per meter square it will come. So we know the theta here. We know that theta here. At the end of lecture, I am taking screenshots of people joining, student joining. So 750 theta, you know, theta is 21.8 degree. 750 minus 21.8 minus 10 into 20. So for slope more than 10 degree, we have to take reduction in the lie load of 20 Newton per meter square with about 10 degree. That's why here we are going to the minus. It will be coming 514 Newton per meter square. So lie load on purlin you will get 514 Newton per meter square, and that is uh, I will write down that is greater than the minimum lie load, so 400 Newton per meter square. We will consider this one, and because it is on the plan, so we have to convert into the roof. So if we convert this into the roof, so lie load on purlin, lie load on purlin is equal to 514 divided by cos theta, I think so. So it will be 514 into 1.35 into cos of theta 0.928. So if I will write down, so if I will convert into that on the slope P, so 514, and the distance between the two poles is 1.35 into cos of 21.8 degree. cos theta means 21 point, the theta is 21.8. If we find out it will coming, provide or Purlin, this is Newton per meter square, we are converting into UDL, in Newton per meter. Okay, that's why we are multiplying this spacing. Spacing is equal to slope, so it will be uh, 643.94 something on if I it is in plan, the spacing is 1.35. Okay, so this is the slope is x, I think so, theta, so cos theta is equal to 1.35 upon x, so x is equal to 1.35 upon cos theta, I think so, sloping portion. So here we have to divide this rather than multiplication, I think so. Or I am right? Cos theta is equal to adjacent upon hypotenuse. So hypotenuse we don't know. 1 upon 1.3 by cos theta, barabar, it is divided by cos theta. Okay, the value will be changed something. What to change the value? Value will be so 514 into 1.35 divided by the bracket cos of 21.8. That is coming something 747.34. मैं कुछ गलत कर रहा हूँ. Oh, something I'm doing wrong. The sloping spacing is given 1.35 into purling spacing is given. So that we are doing that is right. Sorry for that. So this is given 1.35 and we have to convert into plan. This is our x. Sorry. This is our x. So it is okay. It's okay. This is our x. And this is 1.35. So it is okay. So x is equal to, so cos theta is equal to x upon 1.35. So x is equal to 1.35 cos of theta. It's okay, okay, no issue. And it's coming something 643.94. So if you convert this in Newton per meter, it is approximately, I will write down 644 Newton per meter. Okay. So there is lie load on the purlin, right? Then wind load is already given. So already wind load acting perpendicular to the sheeting. Wind load acting perpendicular to sheeting. So directly we will take minus 117 into, this is in Newton per meter square. We have to convert to real on the purlin. So you have to multiply 1.35. So it will be minus 1580 Newton per meter. And it is normal to roof. It is perpendicular normal to sheeting. Okay, normal to sheeting or perpendicular to roof or perpendicular to sheeting, just window. So all the load coming on the purlin we have calculated in UDL. So we have converted into UDL. Now, so this actual our load on the purlin is coming. This is our purlin on the inclined portion. On purlin is in inclined portion, you can say. Okay. So load may be like this. So you have to make a, the vertical load we have to make a component parts. So you have to take a component parts in its own direction. So step number three, you have to component of loading along component of loading component of loading along x-axis local axis I'm saying local axis parallel to parallel to is also called as major axis and along y-axis and along y-axis it is perpendicular to root. Okay, perpendicular to root or normal to root, whatever it is. Okay. So first our load is dead load. So dead load along y direction this cos theta. So you can see here this is your first you will understand purlin. This is your purlin. Whatever direction it may be size. This is the loading. So this is x direction. This is what component in the. So this is theta. So this will be theta. So along the theta, this is the cos theta, है ना? So if this value, something value, so it will be p cos theta, and horizontally it will be p sin theta. Theta is there, okay? So theta here is 21.8 degrees. You know that. We already calculated the theta first. So now the dead load, two components are there, y component and x component. Vertical component or horizontal component, you can say. W is load and UDL is there and Y is in the Y direction. Okay, that is Y means this vertical direction. So 276 is our load into cos of theta. So cos of theta is 21.8 degree to 276 into cos of 21.8 degree. It will be coming 256 Newton per meter. Similarly, dead load in x direction WDX, that is horizontal component. So it is vertical component of loading, and this is the horizontal component of loading. Okay, so the 276 into sine of 21.8 degree, and it is coming 102.5 Newton per meter. 102.5 Newton per meter. Okay, so I think so you are understanding this. Okay, so please do write down, though you can only understand. Then again the component of the lie load, components of lie loads. So you have to write down components of lie load, or you can say imposed load. So WLY, the vertical component, it is 644 cos of theta. Okay, it is nothing but 598 Newton per meter. Similarly, WLX, horizontal component, 644 of sine of theta. Theta is 21.8 degree. So it will be 239 Newton per meter. Okay. Now the components of wind load. So wind load around y direction, it is minus because of lift. That's why minus 1598 into cos of 90. Cos 90 is 1. It is perpendicular. So it is minus 1580 Newton per meter. And horizontal component, the sine 90 is nothing but it is 0. So the whole term will be 0. It is 0. So there is no horizontal component in case of wind load. Okay. So in step number 4, Step number 3 we have done. The step number 4. Now we are finding out in step number 3 the components of dead load, lie load, and wind load in two directions. Now we will take the combinations. Now we will take the combinations. So there are different load combinations we will take in step number 4. The load combination, the load combinations will be first. First combination we will see there is 1.5 times of dead load plus live load. In case of IS 800 2007, that load combination is given. So, 1.5 times of dead load plus live load. So we have to take vertical component and horizontal component both. So if I write on WY1, the vertical component, 1.5 times dead load of vertical component is 1256. Y dead load of live load of vertical component is 598. Okay, so 598. So it will be okay 1.5 times, and then it will be coming 1281 Newton per meter. Okay, this is the factored load. This is the factored load. Factored load because we are multiplying with 1.5. That's why that is the factored load. And Wx1 in horizontal component of dead load and live load. This first combination, I will write down the capital A for first combination. So 1.5 times of x component 102.5 in case of dead load, in case of live load is 239. So it will be 512 Newton per meter. It is also factored. Now second component as per the ice code you will take, it will be 1.5 times of dead load plus wind load. This is the second combination. So if I write down WY2 is the vertical component of this four combination. So 1.5 into dead load is 256 in y direction and wind load is minus 1580. So it will become minus 1986 Newton per meter. Similarly, if you go for the x direction, that is horizontal direction, WXT 1.5 times of dead load is 102.5 minus, there is no horizontal component in case of wind load, minus 0, it is positive 154 Newton per meter. Now we'll take the third component, I will write down capital C, the combination of load. Third combination is 1.2 times of dead load plus live load plus wind load. You may go another combinations also. It is not limited to these three only, but in case of this, your understanding, you are going for the three combinations. So you write down this combination to 1.5 times of, 1.2 times of, 1.2 times of dead load हमारा 156 है, the y direction में, plus live load 598 minus 1580 is one load, so it is will be coming minus 871 Newton per meter. Similarly, the x component of this combination about C combination, so 1.2 times of this is 102.5 plus 239 minus 0. There is no horizontal component for the wind. It is coming 410 Newton per meter. You may take another combination as per your requirement. So here only three combinations we have taken. Okay. In that case, the worst combination in x and y direction you to find out. If you see here, so maximum value for the loading here in vertical direction, so this one, y component, and maximum loading in horizontal direction is plus. So, so what combination? So this is, you can see that it is the worst combination. So worst combination is this one, when the 1.5 times of dead load plus wind load. So we will take it is for design. So for design, if you so loading, thus 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 amount above combination of load above three combinations. You may go for 4, 5, 6 and many combinations, that is 1.5 times of dead load plus wind load is the worst combination is critical. So we'll go for that. So that is WY2 is 1986. Negative sign is for uplift. Negative sign is for uplift. Okay, and WX2 is 154 Newton per meter for the worst combination. Now, the bending in the two direction, the bending moment you have to find out is step number 5. Step number 5, you have to find out the bending moment, bending moment, bending moment in x and y direction, in vertical and horizontal both components, because the two components of loading is there. If you write down, so mx, I will find out. So wy, तो ट्रांसवर्स लोड क्या अनदर डायरेक्शन का जो लोड रहेगा एल स्क्वायर अपॉन 10 एल स्क्वायर इज द स्पैन तो डब्ल्यू वाई इज 1986 into span is 3.5 meter divided by 10, so 2432.85 newton meter is your moment in x direction or about the major axis. About the minor axis, if you find out Wx into L square upon 10. Wx in this our worst case critical combination is 154 into 3.5 square divided by 10. You find out it will be 188.65 Newton meter. So this is step number 5. You have to find out this. Now you have to select the section. Selection of angles. So step number 6. Based on this moment, you have to find out selection of selection of selection of angle section. Selection of angle section. So generally, selection of angle section is done based on the section modulus. In case of beam, the selection of angle section based on the section modulus. So if I will write down the Z required, section modulus required is nothing but the maximum moment is mx upon 1.33 into 0.66 into fy for purlin only. This for purlin in case of angle purlin. So you can write down mx is 2432.85 Newton meter. Okay, divided by 1.33 into 0.66 into 250 is that what? It is 11086 mm3. So always your trial section will be larger than this. So now I will selection of angle section based on width and width. So as per IS code, width of angle, width of angle, who is disturbing the class, I will remove him. Width angle parallel to roof, the IS code is given, that is L by 60 is equal to L is 3500 mm 60, so it will be 58.33 mm. Now depth of angle, depth of angle perpendicular to roof, perpendicular to roof, or you can say normal to roof, is equal to L by 45. This clause is given IS 800 2007. From that I have taken. It's not from my side. 45 is coming 77.78 mm. तो one leg is 77.78, तो 75 का नहीं जा सकते, तो I will go for 80 or 90. So here choose, because in our example it is given that you have to choose the equal angle section. Choose equal angle section, meaning both legs should be same. Equal angle section. 80 is greater than 77, so I will choose first try 80 by 8 mm. I will, for my first try, I will choose the angle section 80 by 8 mm. Now you have to do the section classification, and your section should be within the complex class. So I will. This is the our selected section. This is the our selected section. This is the our selected section. Okay. Now this step. Who is disturbing the class? I will remove him. Okay. It is so disturb. So step number 7, I will write down. Step number 7. So section classification. So you have to check that your section should not be cylinder. Section classification we are doing, and from the section classification we should know that the beta b value also. Okay, so that is very important. Okay, so in case of angle section from table number table 2 of IS code we are doing IS 800 2007. इसके बेस पे हम क्लासिफिकेशन b by t is equal to 80 by 8 is 10. 10 is much less than 15.7 epsilon, so it will be semi-compact class. So angle section are always in semi-compact class. Similarly, d by t 80 by 8, that is also 10, which is less than 15.7 epsilon. It is also in semi-compact class. So section is also, and then b by d upon t ratio, that is 80 plus 80 upon t is 10. So 160 upon 10 is 16. 16 is less than 25 epsilon. So it is also in semi-compact class. Okay. So our section fusion section ISA 80 by 8 is in semi-compact class. Okay, it is not cylinder, so it's okay. Okay. Now we know that this is our number. Now you have to find out. So in case of this beta b for this semi-compact class is nothing but Z upon ZP. Okay. So it is given in IS code. Beta b is equal to 1 for plastic section and compact section. Okay. And beta b is equal to ZE upon ZP, 1 upon shape factor in case of semi-compact class. So this is our semi-compact class, and beta b is equal to ZE upon ZP. Now we have to find out the moment of resistance in X and Y direction. Okay. I will write down step number 8. So you have to find out moment of resistance or design moment calculation. calculations. So you know that MD in case of design of beam, it is nothing but MD is equal to beta B ZP into Fy upon gamma MO. But here beta B in case of semi-compact limit, that is ZE upon ZP. Okay? So MD, if I will write down, so ZE upon ZP into ZP into Fy upon gamma MO. So this will be cancelled. So the MD formula in case of purlin, this is Z complex section in angle purlin, ZE Fy upon gamma MO. Okay. Now in our case, you can see that the angle purlin, this figure you should understand. Huh? You should understand this figure. Draw this figure. The angle purlin on your sorry on the angle purlin is on principal rafter. Principal rafter. So this is the cleat and this is your angle purlin. Okay. Okay. So this is your axis in x direction, major axis, local axis, and in y direction. These are the point A, B, and this point C I will write down. Okay. So you know that what Z is the section modulus and Z is equal to I upon Y. Okay. So if I write down the MDX, so MDX will be ZXX into Fy upon gamma MO, है ना? और MDY अगर मुझको मालूम कर दो तो that is ZYY into Fy upon gamma MO. Now you have to find out ZXX and ZYY. So ZXX is equal to okay. So you can see this the ZXX. So this is the section. So rotation will be about this axis in both directions. Okay. So ZXX is equal to IXX upon, I will take the bottom side, it is large, that is B minus CXX. So if I will see, this is the CXX, this is the CYY, this is CXX, and this is the total B. Okay, and this distance below, this distance I will write down. This is nothing but B minus CXX, and this distance is large. Okay, so CXX in case of this angle is 22.7. So B minus CXX, our B is 80 minus 22.7, it is 57.3 mm. So it is large rather than this. So I will go for the bottom portion at C, the rotation will be critical. So I will write down. So Z is IXX is 72.5 into 10 raised to 4 divided by, that is 57.3. Okay, so it will be ZXX is equal to sorry ZYY is ZXX is equal to something wrong. Is equal to sorry is equal to CXX into, so it will be 22.7. So it will be 72.5 into 10 raised to 4 upon 22.7 is coming 31.94 into 10 raised to 3 mm cube. Similarly, ZYY is equal to, from the bottom, is 72.5 into 10 raised to 4 divided by that Z, that B minus 80 minus EXX 22.7, that is 57.3. It is 12.65 into 10 raised to 3 mm cube. Okay. So now we can find out MDX is equal to ZXX upon into Fy upon gamma M0. So if we write ZXX is 31.94 into Fy is 250 upon 1.1. So it will be 7259 Newton meter, which is greater than 2432.85 Newton meter. Okay. Similarly, MDY is equal to 12.65 into 10 raised to 3 into 450 divided by 1.1. So it is coming 2875 Newton meter, which is greater than 188.65 Newton meter. Okay. So now in step number 7 we can check. Step number 9 we can check the mx upon mdx from the interaction equation, my upon mdy, that should be less than 1. So if I will write down this value, mx is 2432.85, mdx is 7259 plus my is 188.65 and mdy is 2875. If I write this value, find out 0.335 and 0.0656. If you do the addition, it will be coming 0.4006, which is less than 1. So our design is okay. For instance, this our section is okay. So you can write down the note that as the requirement of limit as the requirement of limit state of strength, state of strength is satisfies hence chosen section is okay, or selected section. Okay. So that is the design of your purlin. Okay. So here we are finished. If you have any doubt, you can ask me. Or this is the design, and tomorrow we will start the design. You can see the how to design the entry ladder, and then one is number 5 is also here. So if you have any question, you can ask me or otherwise. So these are 5 steps for design of your angle purlin, and it is nothing but you have to find out the moment, load calculation, moment, and based on the moment you have to find out Z required and above Z required, and this criteria width and depth of angle as for the span by 60 and span at 25, you have to select the angle section, and then choose an action angle section. You have to check for the design moment, and your design moment must be greater than this is the design moment must be greater than the moment in x direction. Design moment in the y direction must be greater than the moment in y direction, and then in the interaction this equation, and this equation the strength check If this is less than 1, then you can say that our design or selected section is okay. So this is all about the design of purlin, design of angle purlin. It may be asked in examination for 10 marks, for 8 marks, but you should know how to design. Okay. I will share this sheet also. If you have any doubt, you can ask me. Otherwise, we will stop. कोई क्वेश्चन है किसी को? Okay. No question. So we will stop here.